So in this question, we have a researcher claims that, okay, we have our claim, 86%. Again, when you see percent, you quickly remind yourselves of proportion. Not the mean, not the standard deviation, just the proportion. Of college graduates say their college degree has been a good investment. Okay. 80%. Do you see any less than, greater than? 80%, exactly 86% say something. Exactly. It means that our null hypothesis is given. The proportion is exactly 86%. So our claim and our null hypothesis are the same. Alternative hypothesis says, hey, it's not exactly 86%. Well, in a random sample, okay, our keyword, sample, 1,000 graduates, N is equal to 1,000. 845 say their college degree has been a good investment. 845 is your X. X is 845. So you can quickly form your p-hat or sample proportion, which says, hey, this is X over N, or 845 divided by 1,000. 0.845. This is your p-hat. We found our p-hat or sample proportion. Alpha is given to us 10%. At 10%, is there enough evidence to reject the claim or reject the null hypothesis? Well, they have to follow the instruction. First, check to see if it satisfies normality or not. N times P. Guys, this is p-hat. It's not P. P is 86%, 0.86. So 1,000 times 0.86 is 860, which is of course greater than equals to 5. We don't have any problem with that. N times Q, which says 1,000 times 14%, which is equal to 140. This one is also greater than equals to 5. We don't have any problem with that. So now we can use our z-test to check to see if it's in the rejection region or not. Take a look at your null and alternative hypothesis. This is a two-tailed graph. Two-tailed. Alpha is given to us as 10%. It means that half of alpha is on the left, half is on the right. So when we want to find the critical value, so to find the critical value, we use inverse norm for alpha divided by 2, or inverse norm of 5%. 5%, not 10%. Turn on your calculator. Okay, let me just clear this one. Second vars. So inverse norm, 5%. It gives me negative 1.645. Negative 1.645. And remember that since it's a two-tailed graph, you have a negative and a positive critical value. Okay, how about our standardized test statistic? Z, or a standardized test statistic, is equal to p hat minus p divided by square root of pq over n, or p hat minus p divided by square root of pq times square root of. By doing the calculation, our standardized test statistic is almost negative 1.37. Is this inside the rejection region or not? Our rejection region is divided into two pieces, negative 1.645 and positive 1.645. These are the critical values. Negative 1.37, negative 1.37, it's outside the rejection region. Outside. The green region. What's the meaning of that? It means that we fail to reject the null hypothesis, or we fail to reject the claim. What's the meaning of that? There is not enough evidence at 10% level of significance to reject the claim that 86% of college graduates said their college degree has been a good investment. Let us take a look at our calculator, double check this. We go to stat, we go to tests. We need to find one proportion Z test. P sub 0 is 86%, so 0.86. X is 845. 845, and N is given as 1,000. And remember that it's a two-tailed test. Let us do the calculation. So as you can see, your p-value is 17%. You can say that, hey, p-value is almost 17%, which is greater than alpha, or 10%. This is your alpha. What's the meaning of that? It means that we fail to reject the null hypothesis.